let's talk about other number-based systems. So the number-based system that we are used to is base 10, right? Everything is based on powers of 10, but that's not the only way that we could describe numbers. So we're going to look at a couple other base systems, and we're going to start with the base 5 system because we can describe that system using our hands, okay? So if I start with one hand and I have 0 fingers, that's going to be 0 base 5. And then on the right column, I've got the image using the blocks. Okay, so hold up your hand. If you have one finger, that's 1 base 5 or just one block. Same for 2, 3, and 4. Now when I get to 5, I've got my hand up here, and what I have is one hand and no fingers. So I'm going to represent 5 in base 5 as one hand and 0 fingers. So you can think of your place values here as hands and fingers. And so 1, 0, base 5 represents what we think of as 5 in base 10. The image we have now is anytime I get 5 of something, I glue it together. So I have 5 blocks, I glue them together to make a long in base 5. And we can continue counting. So if I add another 1 to what I had before, now I have one hand and one finger, that's going to be 1, 1, base 5. And that's one long and one unit, base 5. You can see what happens with 1, 2, 1, 3, 1, 4. Now what happens when I add another unit here at 1, 4, I've got another block, or I've added another finger if we're thinking about the hands. That's going to give me 2 hands now and 0 fingers. So that's 2, 0, base 5. In terms of the picture, since I added this extra block, I have 5 blocks here that can be glued together to give me the long, right? So I have 2 longs and 0 units, and you can continue counting that way. Let's look at how we would convert back and forth. So I want to take a base 5 number, 1, 1, 2, 4, 4, base 5, and convert it to base 10. So these place values, starting from the right, are telling me how many of each power of 5 I have. So on the right, I've got 5 to the zeros, 5 to the first, 5 squareds, 5 cubes, and 5 to the fourth. So this is telling me 1 5 to the fourth, 1 5 cubed, 2 5 squareds, 4 5 to the first, and 4 ones, or 5 to the zeros. Okay, so that's what I've written out. I need to add all of that together. I've done the math for you here, right? So I've taken 5 to each of the appropriate powers, and then I multiplied and added together. So this is equal to 824 in our usual base 10 system. All right, let's look at another base system. The binary system is base 2. We only have 2 digits. We get a 0 and a 1. And now every time I get 2 of something, that's going to move me up a place value. Base 2 is especially important because it's used with computers. We can think of one of the digits representing a signal that's on and one that's representing a signal that's off. So base 2 comes up in some practical applications. Let's try converting a base 2 number to base 10. So again, you want to think of starting from the right, and your place value now is powers of 2. Whoops. So I've got 2 to the 0 here, 2 to the first, 2 squared, 2 cubed, and 2 to the fourth. So this is telling me I have 1 2 to the fourth, 0 2 cubes, 1 2 squared, 1 2 to the first, and 1 2 to the 0, or 1 1. And so I've written this out. I'm going to add up those numbers, and I get 23. So that's how we're going to convert if we start with some base, converting it to base 10. What if I want to go the other way? So I want to convert 27 to base 2. So now I want to write 27 in terms of how many of each power of 2, how many of those build 27. So we're going to use a little trick here to do that. So the first thing I want to do is think about what's the highest power of 2 that is still less than 27. So let me write out my powers of 2. I have 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. And 2 to the fifth is 32, and that's going to be too big, right? So let me, erase that 2 to the fourth. And we're going to start with 16. Okay, so what we're going to do is think about how many 16s I could pull out of 27. And I'm going to draw a little picture like this. So there's 1 16 in 27. So what I'm going to do is subtract 16 from 27. I'm left with 11. And now I'm going to move on to 8. How many 8s go into 11? Well, just 1, right? So I'm going to subtract 1 8 from 11. I have 3. And we're going to repeat. How many 4s go into 3? Well, 4 is bigger than 3. So 0 4s go into 3. So I'm going to subtract 0 here. I'm still left with 3. And now I'm looking at 2 to the first. How many 2s go into 3? Just 1. I'm going to subtract 2. I'm left with 1. And finally, how many 1s go into 1? Just 1. Now I want to read my number. I'm going to read down to get that 27 is equal to 11011 base 2. Right? What this says is that 1 times 2 to the fourth plus 1 times 2 cubed plus 0 times 2 squared plus 1 times 2 to the first plus 1 times 1 equals 27. And I'll leave you to double check that. All right? Let me show you another way that you could figure this out. So what we want to do here is we are going to divide 27 by 2 repeatedly. Okay? So when I divide 27 by 2, I'm going to get 1 3 with a remainder of 1. And now I'm just going to repeat again. So divide 13 by 2. 6 goes into 13. 2 goes into 13 6 times with a remainder of 1, right? 2 times 6 is 12. 13 minus 12 is 1. I'm going to divide this by 2. I get 3. And with a remainder of 0. I'm going to divide 3 by 2. I get 1 with a remainder of 1. And now I can't divide by 2 anymore. So I'm going to start with this number and I'm going to read that way. So I'm going to read up, not down. And so what I get is 1 1 0 1 1 base 2 is equal to 27. All right, so you can use either one of these methods to help you convert to base 2. If you were to use this method over here on the right, what I'd like to see is an explanation here, because the explanation is not quite as clear from your work. The one on the left, you can see what's happening a little more clearly. Okay, so I've done this twice. Let's look at another base system. The base 12 system is called the Dewey Decimal System. And when we get to what are usually double-digit numbers, like 10 and 11, we're going to use letters to represent those numbers. So T is going to represent 10, and E is going to represent 11. So the digits we have in base 12 are 0 through 9 that we usually have, and then T and E. Let's try converting from base 12 to base 10. So again, you want to think of your place values starting from the right. So these are 12 to the 0, 12 to the first, and 12 squared. And so what this says is that I have E, or 11, 12 squareds, 2, 12 to the first, and 10, or T, 12 to the zeros, or ones, right? So I'm going to write that out, multiply and add, and I get 1618. So 1,618 is the base 10 representation of this number. All right, let's try converting the other way. So I want to convert 1,277 to base 12. So I'm going to use the same method that we used when we converted to base 2 on the last screen. So I want to start by thinking about the powers of 12. So 12 to the 0 is 1, 12 to the first is 12, 12 squared is 144, and 12 cubed, 12 cubed is 1728, which is too big, right? That's bigger than 1277. So we're going to start at 12 squared, and I want to know how many times does 144 go into 1,277. Okay, so you should try to figure out what this is yourself. So maybe pause the video and then come back and see what I got. All right, so what I got was 8. If I multiply 144 by 8, I get 1152, and I'm going to subtract that from 1277. I get 125. And now I want to know how many times does 12 go into 125? Well, 10 times, and since I'm in base 12, I'm going to use a T to represent the 10. So that's 120 when I multiply 10 times 12, and I'm left with 5. And now I'm looking at 1. I want to know how many times does 1 go into 5? 1 goes into 5 times. And remember, we read this down. So I have 1277 is 8T5 base 12. Make sure you put that subscript down there so we know that you're working in a different base. Now you could use the other method too, so let's just run through that quickly. So here I'm going to divide. So I want to divide 1277 by 12. I'm going to get 1, right? 12 goes into 12 once. It goes into 7 0 times, and it goes into 77 6 times. 12 times 6 is 72, so I get a remainder of 5. And now I'm going to divide again. How many times does 12 go into 106? 8 times. 12 times 8 is 96, so I get a remainder of 10. And I can't divide 8 by 12 again, so I'm going to start with this 8 and read up. So I get 8T5 base 12, which is the same thing I got with the other method.